Hello, welcome to Code with Richard, and in this episode, I will be solving LeetCode problem number 32, longest valid parentheses. So let's get started. So I've copied and pasted the problem definition from the LeetCode website. Given a string containing just the characters open paren and close paren, find the length of the longest valid or well-formed parentheses substring. And it provides us with some examples. So the first example has two open parentheses and a closed, so the output should be 2. And the explanation is the longest valid parentheses is this section right here, where you have an open and close. Likewise, we have another example too, where you have the longest is 4 parentheses. So you have an open, close. And then another example where the input is nothing, in which case the output should be 0. It gives us some constraints here. Nothing's really notable except for there's only one type of parentheses, which is like a standard open and close parentheses. And it gives us a um, what our method should look like. Okay, so where to start? And I broke this down into basically two problems. So I'm going to call these sub-problems. Um, and the first sub-problem, which I think is a harder one, is answer the question is which parentheses are valid? So another way to say that is if they're valid, if they're matching, because that seems, in my opinion, the hardest part of this particular problem. And I decided to do this in a left to right reversal. And let's talk a little bit more about why this is essentially a hard problem. Well, there's two cases. So case, I'll say open, parentheses. So when we do a traversal, there's only going to be two strings, and you have an open paren. And when you encounter an open paren, you actually don't know, does this parentheses match? And we actually don't know. So I'm going to say you don't know if part of matching pair. And I'm going to say that you must traverse remainder of string to know. Because when you get an open parentheses, yeah, you have no idea what comes after it. And the other case is when you get a closed parentheses, you can immediately know if this is part of a pair. Because it would match a previous open paren. I'm just going to shortcut and say paren instead of parentheses. Okay, so when we do a left to right traversal, these are basically the two cases that we're going to encounter. Open parentheses, but at this point in time, you have no idea if it's matching in a closed parentheses. But when you get a closed parentheses, you know if it's matching because it would match a previous open parentheses that has not already been matched. But if there's no open parentheses that have already been matched, then you know it does not match anything. And so I'm going to tell you my strategy for this. And there's actually two steps in this strategy. And the first step is basically identifying which parentheses are part of the matching pair. So we're not concerned about counting at this point in time. So we want to identify which parens are part of matching pair. Okay. It sounds simple, but it's actually, I think, a little bit harder. And then, so this is step one. Step two is once you know which parentheses are part of the matching pair, is just count, oops, count longest group of matching parens. Okay, so let's go ahead and get a couple examples here to see what I mean. So first example, my input, maybe I'll have something that looks like this. And so you have open paren, and then we have two groups of matching parens, and then this actually matches. So in this case, they all match. Because remember, they could be nested, or actually it didn't say any. It didn't explicitly say they could be nested, but yes, uh, the parentheses can be matching. So in this case, the first step would be, my opinion, in this strategy, is to determine which of these are part of a matching pair, and they all match. So I'm going to put T for true. So the, each of these parentheses is part of a matching pair. And I'm going to do another example. Let's say I have a matching pair right here. So that matches great. Let's say I have a closed parentheses. And then I have something that looks like this. Let's go through. See and through. So matching. So these first two are matching. This closed parentheses right here, this one's not matching because there's no open parentheses for it to match. But I also know that the next four are matching. Put that here. And then this last open parentheses is not matching. Okay, so remember, this is step number one. Identify which prints are part of a matching pair. And so this is the hard part. In this case, all the parentheses are matching, but in this case, there's a few parentheses. This closing parenthesis right here and this open parenthesis right here are not matching. And so how are we going to calculate this? Because it's not necessarily straightforward. Um, from above, what I mentioned before is that if we do a left to right traversal, when we see an open parentheses, we actually don't know at this point in time if we're part of a matching pair. We actually have to wait and see if the parenthesis matches later on. So the way that I'm going to do that to track that is I'm going to use a stack. Okay. Um, so I'm going to repeat that. I'm going to do a left to right traversal. So I'm going to use a stack. And to keep track of the open unmatched parentheses. To track open unmatched runs. Okay, so in this case right here, you have a couple of consecutive open parentheses, and as we're traversing, we don't know if they're going to match or not. It's only until we hit closing parentheses later on that we know that these two parentheses match. And I don't want to store just the parenthesis itself because anything on the stack we know is an open parenthesis. I want to store the index into the original string. And the reason why I want the index into the original string is, let's say we have an open parenthesis and we don't know if it matches. There could be a ton of other open parentheses that are unmatched, but the first closing parenthesis is not going to match the most outermost parenthesis. It's going to match the innermost parenthesis. So for example, when I hit encounter this closing parenthesis, I know it matches my most recent open parenthesis. So I need to know what index this parenthesis is so that in this matching array, I can mark it off as true as being matching. So I'm going to say, so this stack will contain the index of the open paren in the original string. I was going to put a note here. This allows marking the corresponding position in matching to true when the open paren is found to be a match. Okay. So there's a couple of notes that we can keep in mind is that we're going to push all open parens to stack. Well, actually, I'll say all open parens index stack, and then pop matched open parens off stack. So when I encounter an open paren, I'm going to put its index on the stack. When I encounter a closed paren, this closed paren will match the topmost open paren on the stack, and in which case we know it matches and we'll just pop it off. And at that point in time, if it matches, we can go back into this matching array or excuse me, list, and mark the corresponding indices as true. Right? So let's go down and take an example. I'm going to just copy and paste from off screen. Oops. And oops, excuse me about that. Oh, did not want to do that. Excuse me. All right. All right. So here's my input. I'm also going to say what is my matching. So I'm going to initialize my matching to all false. In here, I'm going to start off with my index equals to 0, and I'm just going to put a little caret in here. So this represents my state when I first start up. And then here's my stack. Is nothing. So my input is my input. I'm going to go left to right traversal. I have an index of 0 into the string, and I'm going to look at this open parentheses right here. So what is my logic? I found an open paren, so I'm just going to push my index onto stack. And I'm going to do some copy and pasting. So I'm going to copy my state right here. So again, this is the state of when my index equals 0. I discovered open parentheses as my first parentheses, and I'm just going to push the index onto my stack. Okay. Well, because I'm doing a left to right traversal, I'm going to increment my index. Now I'm going to apply the state. Push my index onto my stack. My index is 0, and my stack, I'm going to put 0 onto here. Okay. So this is my state, and I'll look at my logic, and I have a closed paren. Okay, so I have a closed paren right here, and if there is an open paren that's unmatched, so anything on the stack, then I know it's unmatched. So I'm going to say this matches. So there's two things I need to do. I'm going to pop my open parentheses off the stack because now it matches. And I'm going to mark my matching parens. All right, so let's see how to do that. First of all, let's copy my state. So, and I know that in my next iteration, my index gets incremented to look at the next one. But before I do that, I need to apply the logic here onto my state. Okay, so I'm going to pop my open index, sorry, my open paren off the stack. So the index is 0. So remember that this is the 0. Index 0, pop it off the stack. So now I have no open parentheses. And I'm going to mark my matching parentheses. So I know that my matching parentheses, my index 1 is a closing parenthesis, and that matches index 0, which is a open. I'm sorry. Index 1 is a close, which matches the open parentheses in index 0. So I go up to matching, and my index 0, my index 1, we will put true because I know that these two parentheses. Okay, so basically all I've done for going from these lines up here to here is increment my index from 1 to 2. So I moved the pointer just for illustrative purposes, and I've performed this logic. I've popped my open index off the stack, so now there's nothing on my stack, and I mark my matching parens, which are these two indexes right here, because my open parentheses at index 0 matches my close parentheses at index 1, and I've marked them right here, 0 and 1. Okay, so this is the state of this iteration, and now let's look at the logic. I found a closed paren, and because there's nothing on my stack, I know it's not a match. So I'm going to say no match, and I'm going to say do nothing. I get either, or I could mark the corresponding index to match it as false, but they're basically the same. I just don't want to do anything. And so let's take my state and go to my next iteration. So my next iteration, I'm going to index of 3. I'm going to move this over. Remember, everything stays the same. I didn't touch matching. I didn't touch my stack. The only thing that changes is my index goes to 3. So I move this caret to this open parentheses. And so now I look at my logic, and I have an open parentheses, push index onto stack. All right. So let's go to the next iteration. So for the first thing I'm going to do is, well, just move my index to the next one. But I need to apply this state, push my index on the stack. My index is 3, and I'll push it onto my stack as 3. Okay. And so let's say, what is my logic? I found another open parentheses. So I'm just going to push my index onto stack, just like I did before. So let's copy my state, and I will increment my index, go to the next one, and I need to push my index, which is 4, here, onto the stack. So now my stack will look something like this. Now what I'm going to do is go to my logic, and I have a close parenthesis. So I have a close. And because I have a close parenthesis, and I have at least one open parenthesis in my stack, I say matches, yay. Okay, so what I need to do, pop matching open paren off my stack, and my mark matching friends in matching. Yay. Okay. So let's copy our state and then apply. Let's look at what the state's going to be. Okay. Index of 6. Move this to the next one. Okay. So this is my previous state up here. I'm going to pop my matching open paren off my stack. So I know that my open paren in position 4 in my string is matching. So I can't match anything else. And I mark my matching parens in matching. So I know that my closed paren is in index 5, which is here. 4, this represents my open paren, which is here. So that's these two right here. So I know that these two F's I should move to true. So I'm now marked those positions as true. Again, so what did I do? I popped the open paren off my stack. So this 4 now is now matched. So now I can't put 4 here because only the open parentheses in position 3 is unmatched and open. But I get to mark positions 4 and 5 in my matching array as matched. So I set those to true. So from up here, I set them to true. Okay, so we can just carry on. We can say, what is our logic over here? We have a closed paren, and it matches again. So I can copy and paste some of the logic here. Okay, so that's what we're going to do. So let's copy my state. My index will go to 7. Go to the last one. Okay, so now we get to apply our state. Pop matching open parent off a stack. So that's this one right here. So I pop it off my stack, and I mark my matching parents in matching. So my matching parents, position number 3 and position number 6. So that corresponds to this one's my 3 and this is my 6 right there. So this F is going to turn to true, and this F will turn to true as well. And let's look at my logic. My logic is an open paren. So I have an open push index onto stack. Okay, so let's copy this as well. But this is actually the last iteration, because if I just iterate through here, even though I push it on the stack, it's not going to go anywhere. So we are basically done. So I'm going to say this is done. And then we move on to step number 2, is find longest group of, let's just say T or true in matching. So that's just this right here. Let's just copy this down here. Finding the longest group of trues. And this is relatively a little bit more straightforward. I see a group of two trues, and then down here I see a group of 4 trues. So then my output equals 4. All right, so let's dive into the implementation. So this class, this method definition is what is given to us, so we can just put our implementation into here. So the first thing we do is I'm going to create our array matching. So that's this right here, and say matching, and it's going to be a list. And to make it easy, I just decided to make it a list of booleans, and I am going to initialize to all false. All right, so we'll do a little loop for I in range, and we'll go from 0 to the length of our string s, and we'll just say matching dot append, and we'll just put false right here. So I found this pretty easy to understand. Let's see. So the next thing we want to do is we need a stack. So I need a stack of index of open parens. So I just called mine open paren stack. And this is going to be a list. I use the list because it's ordered. Of ints, because these are the indices into the string. And we'll just initialize this to empty. And now we'll start our traversal. So we'll just do a simple for loop and range from 0 to the length of s. Okay. And this is going to be our left to right traversal. So first thing I'm going to do is I'm going to look at my first element, or I should say my current element, and I'll check to see if it's open parentheses. And actually, let me go ahead and put a comment. I'll do left to right traversal here. Remember, if we see an open parentheses, it's very simple, because at this point in time, we don't know if it matches. All we're going to do is add the open parens index to our stack. So we can take our open paren stack, and we'll just append, and we'll append the index I to that. And that's all we could do when we encounter an open parentheses. Because remember, since we're doing a left-right traversal, we won't know if this particular parentheses matches until we hit a closing parenthesis. Okay, so else. Well, in this case, I have a closing parenthesis. I want to know, is there an unmatched open parentheses to match? And it's actually pretty easy to know, because if I put all of my unmatched open parentheses on this open parent stack, all I have to do is check to make sure that it has elements in it. So, oops, I'll just say if my length of my open parent stack is greater than 0, this means there's an unmatched open paren. So this means I've matched. So I can put this here. Okay, found a match. So there's there's a couple things I want to do. I want to take the index of the open paren, the value of this open parentheses that I found, and my index and my closing paren, I, and mark those in matching as true. So I'm going to mark the indexes of both open and closed paren. And the first one I'll do is mark my open paren. So I can go into matching, and I'll take my most recent open paren and my open paren stack. Remember, I'm just storing the index of the operands in this open paren stack. And I'm going to set this equal to true. Now I'm going to mark my closed paren. So I go into matching, but I is my index of my closed paren, and I'll set that true as well. Now the only other thing I need to do is pop my open parentheses off of my stack. And the reason why I want to do that is because I found a match. It can't match any other parentheses. Pop open stack. So I'm just going to delete it. I'll use del, my open parentheses stack. Okay. And I can optionally put an else here. So I just did this just for clarification. So we can follow the logic. So there is no open paren. If I can see it. So remember, I have a matching open parentheses if I have anything in the stack. But if I don't have anything in the stack, there's no open paren. That's why I'm here. So the current closing paren is unmatched. So I'm just getting my matching of I equals false. And this is actually a no-op. So if we remember in the beginning, we initialized all of the elements in matching to false here. And I'm just resetting it to false. And the only reason why I did this is just for clarity. It's easier, at least for me, when I went through it the first time, to put this here. But we could just delete this and it's fine. Okay, so that's pretty much all we need to do in order to populate this open, I'm sorry, not open parent stack, but this matching. Remember from our examples above, now matching will equal something like this. And now we just need to find the longest group of trues in matching. And that's actually a little bit easier problem to solve. So I'm going to count the longest sequential matched friends. Or this is also the longest sequence of trues in matching. And this is basically like many other optimization problems. I'm gonna create a max longest and a longest so far. Max longest, and there could be many sequences of trues, but max longest is going to be in the maximum one that I see. Longest so far, we'll just count up. We'll count all the trues that are sequential, but when we hit a false, we'll just reset this to 0. So we'll do a little traversal, in range of 0, the length of matching. So if my matching is true, I found a matching ren. So my longest so far, I'm just gonna add 1 to this. And if my longest so far is greater than my max longest, I'll just set my max longest to my longest so far. So if this is greater than my max longest, then my max longest equals my longest so far. All right. And now then else. So in this case, I have an unmatched paren. I just want to reset my counters in this case. So I'll set my longest so far equals 0. Again, I don't want to reset my max longest because this is the one that if I've seen a sequence of n trues or n matching parentheses in a row, then I want to store that. This could be the result that I return at the very end. And let's go out to the end and we'll return our max longest. Okay, that's pretty much it. So let's go ahead and test this. All right, so to test this out, I created a unit test file here using the DDT library. Here are a bunch of test cases. Here's my input, and here's my expected output. So I just tested a couple different cases, making sure to test closing and open parentheses as non-matching, some shorter, some longer ones. Not really much to see here. It's more interesting when we go and run this, and we'll run it, and all the tests pass. So yeah, that's pretty much it. That's the solution that I worked on for a little bit and came up with. And thank you for joining Code with Richard. I hope you enjoyed this episode. If you have any questions or comments, please leave them in the comment section on this video, and hope to see you next time. Thanks.